Okay, so we're going to start with a simple lesson that is really just review for you, and it's properties of exponents. So my little rule up here says that A and B are going to be real numbers, and M and N will be integers. And so we're just going to go through these, do a definition and a rule, and then show a couple of examples. And so it shouldn't be anything that it's not anything that you haven't seen before. So a product of powers, it just means that when you multiply like bases, you add exponents. And it looks like this. The rule looks like this. If I have x to the m times x to the n, then that gives me x to the m plus n. So let's do it with numbers now. If I've got x squared times x cubed, I've got x to the fifth because 2 plus 3 is 5. If I have z to the fifth times z to the fourth, then I've got z to the ninth because 5 plus 4 is 9. So if you're multiplying and the bases are the same, you add the exponents. Next is your quotient powers. And all it says, the rule says that if I am dividing like bases, then you subtract your exponents. The deal with this is you want to subtract so that you subtract the small number from the large number, wherever it may be. So if you have, for example, x to the m over x to the n, if this number is bigger, then you're going to do x to the m minus n. So I'll give you a couple of examples. If I have x to the fourth over x squared, then I'm going to have x to the 4 minus 2, so I'm going to have x squared with no denominator. If I have, I'm just going to flip that. If I have x squared over x to the fourth, then I'm going to subtract 2 from 4, and since 4 is in my denominator, I'm going to have x squared on the bottom because 4 minus 2 is 2. And if everything comes out of the numerator, you've got to have that placeholder of 1. Because here's the quick explanation, that has an understood coefficient of 1. And so if I take the x squareds to the bottom and subtract them, then the 1 is still there. Your zero exponent is a really nifty rule. I like it a lot because it's kind of that no-brainer. You don't have to think too hard about it. Anything raised to the 0 power, I should say any number if I want to be mathematically correct, right? And I should learn to spell. Any number raised to the 0 power is 1. Any number raised to the 0 power is 1. If you don't believe me, plug it in your calculator. Any number you want to, I don't care how big it is, raise it to the 0 power and you're going to get 1. So if I've got, I'll do numbers this time. If I've got 3 to the 0 power, it's 1. If I've got z to the 0 power, it's 1. If I've got 974 to the 0 power, it equals 1. The next rule is my negative exponent rule. My negative exponent rule says that if I raise a number to a negative power, I'm going to abbreviate here, to raise a number to a negative power, you rewrite as the reciprocal, and that's what makes your exponent positive. I'll show you what I'm talking about. If I have x to the negative n, then that's 1 over x to the positive n. If you take that you're raising to a negative power, you flip it and make the exponent positive. If I had 1 over x to the negative n, then I'm going to flip that and have x to the positive n, writing the reciprocal. 1 over x is just x, and so you just write the reciprocal. So a couple of examples. If I had x to the negative 4, I'm even going to do this. If I had 3x to the negative 4, the only thing that has a negative power is the x. So the 3 is not moving, but the x is, and you make the exponent positive. If I had 1 over 3x to the negative 4, again, the only thing that has the negative power is the x. So the 3 is not going to move, but that x to the 4 is, and you'll make the exponent positive. If you just have a variable z to the negative 3, then it's going to be 1 over z to the positive 3. You just change the reciprocal. I'm even going to throw one more at the bottom down here. If I have x over y to the negative 4, then the y is going to move to the top and become positive, and the x is not going to move because it has an understood positive 1. If it's already positive, then you leave it alone. Okay, the next one is power of a power. That means I'm going to take something that's already being raised to a power, and I'm going to raise it to another power. So when you do that, to raise a power to a power, you multiply the exponents. And the reason, one thing that will help you, a little key that will help you with that, is in math, the word of means to multiply. And so if I have x to the m, and I raise that to the n, I'm taking a power of a power, and so I'm going to multiply those two things, and I'm going to have x to the m times n. If I do that with numbers, so that it makes a little more sense, if I have x squared, and I raise it to the third power, then 2 times 3 is 6. If I've got, I don't know, z to the 4th, and I raise that to the third power, then I have z to the 12, because I'm taking the power of a power, and I'm going to multiply those exponents. If you're taking the power of a product means that you're multiplying things together, so you're going to distribute that exponent. That means everything inside the parentheses, because it's going to look something like this. If I've got x times y raised to the m, then I have to distribute that exponent to everything inside those parentheses. So I have x to the m, y to the m. So here's what it would look like with numbers. If I have 2x to the third power, then I'm going to have 2 cubed and x cubed, and I can simplify that further because we can do the numbers. 2 cubed is 8, and I still have the x cubed. You have to be careful if you have something where it's negative. I'm going to do negative 3y to the second power. I'll do something easy. If you raise a negative number to an even power, that's negative 3 times negative 3, you're going to have a positive answer. So negative 3, you're really doing this. And if you square a negative number, you're going to get a positive answer. If you take a negative number and raise it to an odd power, I'll do that. If you take a negative number and raise it to an odd power, you're going to have a negative answer. I'm going to take negative 3 and cube it. That's negative 3 times negative 3 times negative 3. And that's going to give me a negative 27x cubed. If you raise a negative number to an odd power, it's negative. If you raise a negative number to an even power, it's positive. So this property just says that if you have things in parentheses that are being multiplied, everything inside the parentheses gets the exponent. The same rule applies if you have the powers of a quotient. That just means it's a fraction if you don't know what that word is. So if I had, I'm still going to do the same thing. I'm still going to distribute the exponent. So if I have x over y in parentheses raised to the m, everything in there is going to get that power, x to the m over y to the m. So a couple of examples. If I have 2 over x cubed, then I'm going to have 2 cubed over x cubed, which is going to give me 8 over x cubed. 2 to the third is 8, x cubed is just x cubed. Even if I had, I'm going to mix this up just a little bit because we're going to start doing that anyway. If I had 3x over y raised to the second power, everything in there, the 3 is going to be squared, the x is going to be squared, the y is going to be squared. So I have 9x squared over y. I'm going to go ahead and cover these last 3, even though they are going to be something that we do a little bit later, like in the next day or 2. So we're going to go ahead and do these last 3 things. If you have a product property of roots, all that means is that, and this is going to look weird, the nth root, that just means we're using that like it's a variable, the nth root of a product is equal to the product of nth roots. And that looks really weird. And you're probably thinking, what in the world is she talking about? But all it means is this. If I have the square root of x times the square root of y, I have the square root of xy. I can put them together. So if I had the square root of 2 times the square root of 5, I would have the square root of 10. As long as the root out here is the same, then you can multiply them together. If I had the cube root of 3 and the cube root of 2, I'm going to have the cube root of 6. I keep the index out here. That's when it's talking about the nth root. That's this thing. That's the index outside. You just multiply the radicand, the thing that's under the radical. Quotient property of roots, it works the same way. The nth root of a quotient, sorry about that, equals the quotient of nth roots. And the words can be confusing and you're not really sure what in the world I'm talking about, but it just means this. If I have the square root of x over the square root of y, I can write that as the square root of x over y, and vice versa. If I had the square root of xy, the square root of x over y, I could rewrite that as the square root of x over the square root of y. So if I had, I'll go both directions with this. If I have the square root of 3 over the square root of 2, then I can write that as the square root of 3 over 2. When we start simplifying, we will probably be taking these apart. So if I had the cube root of, I'm going to go with 27 over 2, then I would write that as the cube root of 27 over the cube root of 2. And for the sake of not confusing you further, I'm not going to simplify that, but that's what we're going to eventually get to, is something like this where we can simplify it, because you already know from previous math classes that we don't leave a radical in the denominator. We have to, if you remember what we call rationalize the denominator, we're going to do the same thing here. Last one, rational exponents. If the exponent is a fraction, I'm just going to do it because I can only do a 15-minute video and I'm at 13:57. If I've got the square root of x to the third, then that is the same thing as x to the 1/3. Index comes out here, 2/3. That's an understood 2. I just kind of did an example where I should have done the rule, but anyway, here's the rule. If I have the nth root of x to the m, then that's x to the n over m. If I have the square root of 3 squared, so let's do that cubed, then I've got 3 to the 2/3. If I have the cube root of 4 squared, then I've got 4 to the 3 over 2. This goes in your numerator, this is your denominator. Watch this again if you need to, any parts of it